Okay, looking at one up here. So, in centimeters, how long is the radius?
1.9.
I got 1.85.
Okay, so it's
It's like right between us. How big that?
it's closer probably to 1.9, but it's not all the way. Okay, so how long is the diameter? Okay, about 3.8. Which, how does the diameter relate to the radius? It's double it, right? Diameter is double the radius. Now, to find the circumference, how are we going to do this? Are we going to do it like this and wrap it around like this?
Yeah.
Try to do it like that? That's going to be pretty hard.
Wait, could
But
you?
can you actually do that though?
You could, but it's going to be pretty hard. An easier way to do that, if we were going to do it like that, is just to get a piece of string and just lay the string like around the outside and then stretch that string out on this ruler. But that's all definitely the harder way. What's the easier way to get pretty close to what the circumference is? Good. Remember, circumference is pi times the diameter. So pi times 3.8 is what? It's about 11.94 centimeters. Okay, on the second one, how long is the radius on this one? About 3.8, which means the diameter is what? About 7.6. And then for the circumference. Okay, you guys, too much talking. Too much talking. Need you pay attention, please. Circumference is pi times the diameter, pi times 7.6, which is what? Is about 23.88 centimeters. Again, if we took a piece of string, laid it around there, and then stretched that out, should be about that long. Okay, so that's all stuff we did last week. Okay, so at the top here you have these two just blank circles. Two circles, circle A's. So what I want you to do is, using your ruler, is I want you to draw two chords in this circle A that are 3 centimeters. So the way we're going to do that is I'm just going to take my ruler and put it up inside the circle like that, where 0 is on one edge and 3 is on the other edge. And then just draw that chord from here to here. All right, so if I were to measure that chord, this thing is about 3 centimeters. Now I want to draw another chord inside of here. Sorry. Draw another chord inside of this same circle that's 3 centimeters. Okay, so I've got two chords inside of here that are both congruent, right? I mean, I just drew them, I just saw them, they're both 3 centimeters long. So this chord is congruent to this chord. Now, let's think about this. This chord right here is creating an arc from here to here. And then we have another arc from here to here. So just using common sense, if this chord is congruent to this chord, what do you think is going to be true of this arc and this arc? They're going to be congruent. Okay? So we're going to use that fact as we go through today. Is if you have two chords that are congruent, then the two arcs they create just naturally would be congruent. Okay, on this second circle, what I want you to do is doing your best. I want you to try to draw a line that is exactly horizontal. That's just exactly flat going across here. Okay, and then we're going to draw another radius that try to make it as absolute vertical as you can, going straight up and down. Now there'd definitely be better ways to do this, but just to do this quickly here, if we did this, if we made this exactly horizontal and this exactly vertical, how many degrees should this angle be? 90. Should be 90 degrees. And based off what we talked about last week, if this angle is 90, how many degrees is this arc out here? It should be 90 degrees. Now, what I want to do is I want to draw a chord that connects from right here to right there. Okay, so something about like that. Now ours should be pretty similar, so let's measure that chord that we just drew and see how long that is in centimeters. 3, which I didn't intend for that to happen. That worked out pretty smoothly. So that's 3 centimeters. Okay. Now what I want to do is I want to draw another chord over here that's 3 centimeters. Okay, and so this chord is 3 centimeters. So, since this chord and this chord are congruent, how big or how many degrees do you think this arc is going to be right here? 90. It's going to be 90 degrees, right? Which, like I said, I did not intend for this to happen, but this works out pretty good because it helps for another point I'm going to make. Okay, these two circles are the exact same size circles. I mean, I just copied and pasted, so I guarantee these are the exact same. So, since these two circles are the same, and since this chord and this chord are the same length, how many degrees would that arc be? It'd be 90. That arc would be 90 degrees also. Okay? All right. So, let's go ahead. Let's... Sorry. Okay. So on this first circle here, all right, I'm looking for this arc from S to R. Okay? Now, let's think about this. In a circle, how many total degrees is there? 360. And since this chord and this chord are congruent, what do I know about those two arcs right there? They're congruent. So this one over here is going to be X degrees also. This chord from here to here and this chord from here to here are going to be congruent. And so what should all three of those add up to? To 360. So X plus 64 equals 360. This is one way to do it. So just solving for X here, add combine like terms, so that's going to be 2x plus 64 equals 360 minus 64. 2x equals 296. Divide both sides by 2. 148. Which we could check that real quick. What is 148? 148 and 64 added up to? 148, 148, 360. Okay. All right, on the second one. Okay. This chord and this chord are congruent. We can see that because of this little congruent mark right here. So since those two chords are congruent, I know that this arc right here and this arc right here are congruent. So how many degrees is that arc? It's 116 degrees. Now if that arc is 116 degrees, how many degrees is that angle going to be right there? It's going to be 116 degrees also. All right, number 3. So this one's even easier than all those. So both of those chords are 4, so they're congruent. So the two arcs are congruent, so that means that this is just going to be 82. All right, so number 4, same thing. Since this chord and this chord are congruent, the arcs are congruent. So x plus 90 equals 360. Two x plus 90 equals 360. 270. X equals 135. Okay, on number 5. So on this one, we're kind of working backwards, but it's the same idea. Since the two arcs are congruent, okay, if this arc is congruent to this arc, then that would mean that this chord has to be congruent to this chord. So on this one, we're just going to set 2x plus 4 equal to 18. Minus 4, 2x equals 14 divided by 2. X should equal 7. Okay, on this one, same idea. Since the two arcs are congruent, the two chords are going to be congruent to each other. So 2x plus 1 equals 5x minus 5. All right. So x equals 2 there. Okay, then all three of those are basically the same thing. You can see the two chords are congruent right here, so you just put those equal. Since the two circles are congruent to each other, then those two chords, since the two arcs are congruent, those two chords will be congruent. All that's work out the same way. Okay, let's flip it over and look at the back here. So it says in circle P, the radius is 13, sorry. The radius is 13, RS is 24. Find the measure of each one of these. Okay, so from R to S, it says is 24. Okay, there's a property we'll talk about later, but since this is 90 degrees right here, this radius splits this chord exactly in half. So if RS is 24, how long is RT going to be? It's going to be 12. Okay. So now it wants us to find the length of PT. All right, so PT, let me erase all this. Set that 12 and put that back. Okay, we want to find PT right here. Now, it tells us that the radius is 13, right? So all the way from P to Q is 13, but I don't know exactly where that's going to get split at. There's no way to know that. But what if I draw a radius from here to here? How long is that radius going to be? Okay, let me redraw this. The radius is 13, and I know that this is 12. Okay. So I know from R to T is 12 because it's half of 24. I know from R to P is 13 because it says the radius is 13. So now notice if that's 90, this is 90. We've got a right triangle here. How could I find this little piece right here? Pythagorean theorem, yes. Okay, and on this triangle, I know the hypotenuse, okay? So I know the longer one. So when I know the longer one, the hypotenuse, I'm going to subtract. So it's going to look like this. 13 squared minus 12 squared square rooted. What does that give you? That gives you 5. So PT is 5. That's what we just found. And now I know the whole radius is 13, and this is 5. So how long does it have to be from Q to T? It's got to be 8, which that's definitely not drawn to scale, but that's what it would have to be because these two together have to add up to 13. All right, next one. So on this one it says that the diameter is 12, which obviously means the radius is what? 6. It says that CD is 8, and that the measure of arc CD is 90. Okay. So the whole arc CD is 90, and the first thing asks for the measurement of arc DE. So it's just going to be half of 90. That's going to be 45. Okay, it says that CD is 8. So the whole thing CD is 8. So how long is FD going to be? It's going to be 4. Now I'm looking for the length from A to F. Okay, so if the diameter is 12, the radius is 6, so I'm just going to conveniently draw a radius from A to D. That's going to be 6. And then I'm going to go 6 squared minus 4 squared square rooted. Okay, so AF equals 4.47. Okay, number 7. Circle RTS is 21 and UV is 3x. What is x? Okay, well, if you have this drawn to the same point and this drawn to the same point, and they're both 90 degrees here, then you know that this chord and this chord are going to be congruent. It says TS is 21, that UV is 3x, so 1 equals 3x, which means x equals 7. Okay, and that's going to work out the same way. All that's going to end up being congruent. Just set those equals, so we are good there.